After the database is defined, the next step is to generate the database by processing any new input data by performing signal analysis defined in the database and save all the resulting data plots into database and an analysis report. First turn on database in M1 and select Generate DB in M2. The menu for Generate DB will be shown. First select the desired DB name. Its DB output folder will be dimmed since it can only be selected during define DB. Next select input data sources. There are two input mode: single test mode and multiple test mode. For single test mode, there are also two options available. The first one is using currently open dynamic data file. The second option is using the original dynamic data used in define DB, i.e. the setup test, and the program will automatically find and open it. For multiple test input mode, click the menu button to select all the test data files. Notice that there is no need to select PD file even if performance data is required, that is in input 2 mode, since the program will automatically find the PD files associated with the DD based on the PD type and folder specified in define DB. The next step is processing parameters PP selection. There are three options available. The first one is using processing parameters of the original setup test during define DB, such as the same FFT size for all tests. However, this does not include reference window and PST since the RPM profile and PST for different tests are most likely different. Therefore DBGen will use the reference window and PST of each test rather than the one is setup test. Also, if the input DD is the setup test, then this option will be the default PP option. The second option is using the processing parameters in each DD file. The third option is same as the first option except frequency table, which will use the frequency table in each DD file. This for situations when characteristic frequencies change from test to test. The next step is to specify the processing time for DBGen. For DB pages with processing time set to auto full time, its processing time will be its full time as defined by the start and end time entry box here. If the checkbox for full time is checked, it will automatically use the full time of each DD file. If a DB page's processing time is not set to auto full time, then it will use the same processing time for all input test data, which is the original start and end time specified in define DB. For multiple test mode, there will be a processing time button shown here for setting the full time for all input data. The next one is channel assignment. Since the new input data might have different channel ID or sequence than the original setup data, therefore we need to specify how to assign the correct channels for processing. By checking the box of Use Channel ID for channel assignment, the assignment will base on channel ID. Otherwise, it will base on the channel sequence number in the original setup data. If channel ID are different in the new input data file, then check the box of Apply Channel ID Alias and click the Open button to build a channel ID alias table, such as making XLB an alias of ACC. After channel ID alias is defined, click on Check Channel button. It will check if all the required processing channels from all tests are correctly found. All output data plots files will be saved into the selected database folder for later recall and statistical analysis. In addition, there are several output options available. The first one is Basic Report, which save all DB output plots to a PPT file. Typically one parent plot and one populated plot per DB page. The second option is Advanced Report, which can consolidate and rearrange any plots in Basic Report based on user design layout. The next option, Image, will save all DB plots to image file. The last option, ASCII, will save all DB plots to ASCII file. The default file name for all output options all start with the DB name plus test ID. The lower part of this dbgen menu shows a summary of the DB setup, which is for info only. It is the same table as in the Define DB menu. Therefore, there is no need to set up any information here. Now click Start button and it will start processing the 10 pages of signal analysis as defined in the database. Next, let's see how to define a database that can meet this requirement. Starting page 1, which is to generate RPM and power level profile in reference window. Since power level information is from performance data, therefore the input needs to be set to input to mode as single DD and PD file. Next, turn on reference window button. Select the first option to show its menu. First, set up the speed or RPM profile based on time domain tracking of the speed channel. Also turn on the performance data option to import power level profile from performance database. Then click Save DB. The setup for page 1 is now saved into this DB table. The next page is max-min waveform reduction. Turn on Basic in M1. Select max-min in M2. In Channel menu, select the 2XL channel from channel 5 and 6. These 2XL channels will also be used for all other pages. In Processing Parameter menu, enter 512 as the sliding window size for max-min reduction. Notice that, for analysis time selection, instead of enter a fixed start time and end time, we need to select this Auto Full Time button as a variable time. This way, when process future test data using this database, the start and end time of the new data file will automatically be used as the analysis time frame. Click on this Append and Save DB button. The setup for page 2 is now saved into this DB table. Next, page 3 is for RMS reduction. Turn on Basic in M1. RMS in M2. Select the same 2XL channel. And Auto Full Time again. Click Append and Save. The setup for page 3 is now saved into this DB table. The next page is for composite RMS tracking from 25 to 500 Hz band. Turn on Tracking in M1. Select CRMS or Composite RMS in M2. Select Fixed Band from 25 to 500 Hz. Select the same 2XL channel. Click Append and Save. Page 4 is now saved into DB table. Page 5 is to generate histogram of the bandpass filtered signal from 25 to 500 Hz. In M1 select Basic. In M2 turn on Filter. Select passband frequency from 25 to 500 Hz. Then turn on histogram. Click Append and Save. Page 5 is now saved into DB. Next, set up page 6 for peak RMS tracking at 1 sync frequency 1N as well as its scatter diagram with respect to RPM. Turn on Tracking in M1. Select Peak RMS in M2. Select 1N in M3. Also in right menu, turn on Scatter diagram. In its menu, first select 1 SD reference. From page 1 reference window, select Parent Plot. and select subplot 1, which is RPM profile. Then select 2D scatter diagram for all subplots of the current page. Click Append and Save. Page 6 is now saved into DB. Next, page 7 is phase tracking at 1N along with its scatter diagram. M1 is still tracking, but switch to phase tracking in M2. 1N in M3. Also turn on scatter diagram in right menu, and set up its menu as last page. Click Append and Save to save page 7 into DB. Page 8 is peak RMS tracking at 4N. Switch M2 back to peak RMS tracking, and select 4N in M3. Click Append to save page 8 into DB. Page 9 is for 4-second averaged PSD at multiple time segments of interest, as defined by PST. Turn on Basic in M1. PSD in M2. Then turn on 3 left menu buttons. Match, Peak List, and PST. The PST menu will show the multiple time segments for generating the averaged PSD. User can either enter the PST time segment manually, or use auto-gen mode based on gating of the RPM profile. Select the same to Excel channel. Click Append to save page 10 into DB. The last page 10 for 3D PSD spectrogram. Turn on 3D window in M1. 3D PSD gen in M2. Select the same to Excel channel, and select Auto Full Time again. Click Append and Save to save page 10 into DB menu. This complete defining the DB for Auto Data Package. As demonstrated above, define DB is very similar to regular analysis. The only difference is that after setup in M1, M2, M left and M right menu, instead of clicking on the Start button for regular analysis, define DB needs to click Save DB button, or Append and Save DB button to save the current page setup into DB. More detailed setup information for each page is also shown in the DB menu, such as Test ID, which is input dynamic data file name, M1 menu setting, M2 menu, M3 menu, such as the tracking component at 1N, and 4N in page 6, 7, and 8. Selected channels. Analysis time frame. Frequency info, such as frequency band for page 4 and 5. Also left menu setting, such as the match, peak list, and PST in page 9. Right menu setting, such as scatter diagram in page 6 and 7. If need to perform the analysis of a particular page in play mode rather than start mode, then simply double-click on the cell under this play column to turn on the play mode.